For these next two examples in section 2.5, we're going to be talking about quadratic regression, which is a helpful tool to use when you are given just random points that may be on a quadratic function and you want to find a function that best represents that set of points. So when we go through this, you'll definitely need your graphing calculator out. So go ahead and pause the video and get your graphing calculator out. All right, now that you have your graphing calculator out, let's go ahead and reset it, just because we are going to be typing some data in and we don't want anything in the background ruining our data. So we, again, hit second plus 7, 1, 2, and our calculator should all be reset. So our first example says, find the equation of a quadratic function passing through the points 1, 5, 3, 9, and 8, 1. So we're just going to refresh how to type these data points into our calculator. We did this in our first chapter using a linear regression. Now we're just doing a quadratic regression. So I'm going to hit my stat button still. I'm going to hit enter for edit. I'll type my x's from this list into L1 and my y values from this list into L2. So in L1, I'm going to type in 1, enter, 3, enter, 8, enter. Then I'm going to use my over arrow to get into my L2 list, and I'm going to type my y values. 5, enter, 9, enter, 1, enter, and if I look, my points are now all there. 1, 5, 3, 9, and 8, 1. They all match up perfectly. I don't have something extra in L1 than I do in L2, so I should be good to go, but please make sure that your lists do match up perfectly, because if they don't, then your regression will not work. The nice thing about this problem is it says find the equation of a quadratic function, so we know we're using a quadratic. We don't have to actually get the scatter plot to see it. So if I want a quadratic function, I'm going to hit my stat button again. I'm going to go over to calc. And number 5 for most calculators should say quadrag for quadratic regression. So I'm going to hit enter for number 5, hit enter all the way down. To calculate, your calculator might look a little different there. Some of you might only have to hit enter one time. But here I see that I have a quadratic in standard form, ax squared plus bx plus c, and I'm given the values for a, b, and c that I can substitute into this equation. So I'm going to move my calculator off to the side so I can write this down. I'm going to be writing down y equals negative 0.5, and I just lost my calculator, so I lost the numbers. Go ahead and pause the video and we'll compare our equations in just a second. Okay, so you've paused your video. Hopefully you have the same a, b, and c value that I do, and all you have to do now is substitute the a, b, and c into your equation. Go ahead and clear your calculator. And then for the next example, we have a problem in context. It says the launch angle of a baseball is the angle from the horizontal at which the ball is hit. The baseball will travel shorter or further depending on the launch angle of the ball. The distances traveled for various launch angles are given in the table below. So basically in this table, we're measuring the angle from which the ball is hit, like upwards, and how far the baseball traveled in feet. This time, I do want to actually make a scatter plot of the data to see what type of function would best fit this. It might be linear, it might be exponential, it might be quadratic, but we need a scatter plot to actually see what our data looks like, and then from there, see which regression function fits the data the best. So, back to your calculator. You are going to, again, hit your stat button, hit edit, and you already have things in L1 and L2. So for most of you, if you have a calculator like mine, you're going to scroll up so that L1 is highlighted, hit clear, and then scroll back down, and all of those numbers should disappear. You're going to do the same thing for L2. You're going to scroll up, hit clear, scroll back down. If that's not working for you for some reason, you can always just second plus 712 to reset it, and then it should be clear from there as well. Either way though, in my L1 column, I'm going to type in my top row, the launch angle. So go ahead and pause your video and you're going to type in 10, 24, 40, 48, 58, and 64. I actually just went one step further, and in my L2, I also typed in my distance in feet. So if you still need to do that, again, pause this video please and type in your bottom row into L2. Right. Once everything is typed in and it looks nice, remember now we're not guaranteed that this is going to be modeled by a quadratic. We have to look at the scatter plot to see. In order to do that, again, you already have your data typed in, but we need to make sure that this plot where it says stat plot is on. So you're going to hit second y equals. Right now, plot 1 is off. We're going to hit enter again, and now on is the thing that's blinking. If we hit second y equals one more time, plot 1 now says it is on. If that's not on, you're not going to be able to see your data points when you graph it. Additionally, if you just hit this graph button, you're also not going to see your points because the window is not correct. So instead, first let's just go to y equals, make sure there's no equations in the background here, and if there aren't, you're going to hit zoom, and then number 9 says zoom stat. And here we now see all of our nice points. At this point in the year, we are only familiar with one type of function that can go up kind of in a U shape and come back down. Is this perfectly quadratic? Probably not, but a quadratic function is going to be the best type of function for this set of data. So when it says determine what type of function would be best, we are going to say it's going to be a quadratic. Okay. Part B says find a model for the data using the regression feature on your calculator. Record your equation using 3 decimals, so that means write that down here, and then store the exact equation in your calculator, which is something we did not do in our last section. So if I go back to my calculator and hit the stat button, I'm going to go over to calc. I'm going to hit number 5 for quadrag, but then instead of just immediately hitting enter, I'm going to hit enter down to where it says store regression EQ. If your calculator doesn't look like mine, now you're going to pick up where we are. From here, or from wherever you are in your calculator, you're going to hit this button that says vars. You're going to go over to yvars, hit enter number 1 for function, and enter number 1 for y1. Now, this isn't a totally necessary step to do, but it makes your life a lot easier, and I'll show you why in just a second. We're still going to hit calculate. And just like in our previous example, we now have this standard form equation, which I want you to pause your video and write down, rounding to 3 decimal places. Okay, so you should have paused your video like I just did to write down this equation. Again, the equation here on my calculator is the exact same thing I wrote down on my paper with the correct A, B, and C values. But with that whole vars and function thing, what that actually did for you is if you now click on y equals, your equation shows up in y1 without you having to round or anything. So when we now hit just graph, we see our points and we see the quadratic function that our calculator came up with already being graphed here. Now, again, like I said, it's not perfectly quadratic. It doesn't hit all of these points exactly, but it's pretty close. So we're now going to use this quadratic function to answer the rest of our questions. So part C says, according to your model, what is the angle that will achieve the maximum distance? And then what is that distance? So if we are looking for the maximum, we're going to go back to our calculator. And we're looking for this vertex point, which it looks like it's kind of there, but we're going to make sure we actually use the quadratic function, regression function that we were given. So to find the maximum, we hit second trace, number 4 for maximum. Here's my vertex point. So I'm going to go just a little to the left, hit enter. Now I'm going to go just a little to the right of the vertex, hit enter again, hit enter one more time. And I get that my maximum was 41.14 when we round, comma 283.5. So the point is 41.14, comma 283.5. I need to make sure I'm actually answering the question though. The question is asking what is the angle that will achieve the maximum distance, and then what is that distance? So when I look back up at my table, the angles were my x values. So the angle that will achieve the maximum distance is 41.14 degrees, and the distance is 283.5 feet. Now part D says, according to your model, how far would the baseball travel with a launch angle of 32 degrees? This 32 is an X value. So using my graphing calculator, I'm now going to hit second trace, number 1 for value, and I'm going to type in 32. I know that when the launch angle is 32 now, that the distance is 268.604. Y equals 268.604 feet. And lastly, according to your model, what launch angles would give the ball a distance of at least 200 feet? 200 feet is a Y value. So I need to go to my calculator and go back to Y equals, leave this function alone, go down to Y2 and type in 200, and then hit graph. I see 2 points of intersection there. So I'm going to find those 2 points by hitting second trace, 5 for intersect. I'll go over to those 2 points of intersection and hit enter 3 times. 1, 2, 3. So I know that the first one that will give me exactly 200 feet is 19.5 degrees. Oh my goodness. I have another point of intersection, so if you want to, go ahead and pause your video and do the exact same thing to find that other point of intersection. When I found my other point of intersection, I got 62.779. What we need to realize here is we wanted a distance of at least 200 feet. So if we think about what our graph looked like, something kind of like this, right? We had a distance of at least 200 feet here and my 2 points of intersection here. So here was my 19.5 and here was my 62.779. Anything in between there, any angle measurement in between there would give me a distance of at least 200 feet. So if I were to write this answer in interval notation, I would say including 19.5 and going to including 62.779.